Bismillah ar-Rahman ar-Rahim. We have some questions in chapter 3. I will start with this question. You will find many examples like this one in the old exams. They almost having the same idea. So if you can solve some of them, شباب, I think inshallah any problem just like this one will be so easy. Inshallah, I will try to solve at least today 2 of them. The first one, as you can see, if your mass is doubled and the radius of the earth is also doubled, what will be your new weight? So most of these problems would be the same concept, something that would be changed. It might be your mass. As an example, of course your mass will not be changed, but we have just a kind of imagination. يعني. If your mass is changed, if the weight, your weight is changed, or if the parameters, the scales, the size of the planet changes, what would happen? طيب شباب, how to start understanding this problem? Solving is so easy. المشكلة في how to understand it يعني. And it should be inshallah so easy. He's asking about the weight. So the radius of Earth, imagine that the radius of the Earth is increased to be doubled. So let us assume that was the radius of the Earth, okay? And for some reason, the Earth would be doubled in the size. So the radius would be 2r. This is the first case, and this is the second case. What else? And your mass is also doubled. So your mass was m, and it became 2m. What will be your new weight? So your mass changes, and the size of the Earth, the radius, is changed as well. Of course, I would think that the gravity of the Earth will be changing, and the weight, which depends on the gravity. We know that W equal the mass times the acceleration of gravity. You might wrongly يا شباب, ممكن تخطأ في الحكاية دي تقول خلاص W is mg, the new W, let us call it as W dash for example, will be 2mg. يبقى خلاص the new weight will be 2 times the old weight. This is totally wrong. ليه؟ لأن أنت اعتمدت إن ال acceleration of gravity is the same in the 2 cases, which is totally wrong. ليه يا شباب؟ The acceleration of gravity depends on the size of the planet. The size it changes now, the radius. Remember, G equal G capital, the constant, the mass of the planet divided by the radius of the planet squared. Of course, R here is not like R there. Radius هنا اسمه R, هنا يبقى اسمه 2R. يبقى the acceleration of gravity of this one, let's call it G dash, is not like the acceleration of gravity here. So this solution, this simple one, فكر ان هي بسيطة كده, لا, this is totally wrong. طب نحلها ازاي يا شباب؟ I would prefer to solve it in this way. Let us call the weight. What is the weight, شباب? The weight of the object. The weight, remember, the weight of an object is or equals the the attractive force between this object and the planet. هو قوة التجاذب يا شباب. فاكرينها اللي هي كانت Fg equal G, the mass of the object, the mass of the planet divided by the distance between them squared. يبقى لو بتكلم على الويت, لما اقول weight of any object اللي هي W equal mg, it's at the same time W برضو equal G m of the planet divided by the distance between them squared. طيب. Let us say that the previous, when the radius of the Earth was r and your mass was m, your weight W equal G, your mass now is m, the mass of the planet is m capital, and the radius now is r squared. Then something would be changed. The radius increased to be r, to be 2r, and the mass now, your mass doubled to be 2m. Imagine, just imagine. طبعا الماس مش هتتغير ولا حاجة, بس يعني في المسألة بنقول اعتبري, افترض يعني ان هي 2m. So your new weight, let us call it as W dash, something different than W يعني, will be equal to G the mass of the object now مش هحط بقى m يا شباب، هحط new mass. It's 2m. The mass of the planet is the same. ما قالش حاجة حصلت، هو ما قالش في المسألة إن الماس اتغيرت of the planet. It's the same. So it will be m capital and the radius square. مش هحط r square يا شباب، هحط new radius. So the new radius is 2r. So it should be in this case 2r the whole squared. هنا بس نظبط المسألة المعادلة دي يا شباب. That should be in this case g 2m m capital divided by 2r, the whole square will be 4r squared. Then 2, therefore we have 2 here. يعني we'll be having, look at that شباب, I will just get it out, will be half, اللي هي الاتنين دي يا شباب, half g, then m capital divided by r squared. Now we have calculated the new weight. يا ترى بقى, do we have any relation between the new weight and the old weight? Look at that. This value is this one. So the new weight is half the old weight. W dash equal half the old one. And here we have a similar problem to the previous one. Things that will be changing or finding the weight of the object away from the earth, something like that. But almost we have the same rule, the same steps. Okay. So here we have the International Space Station, this space station that is revolving around the earth, of course at some distance from the earth, orbits and moving around the earth at an altitude of h equal RE over 16, where RE يا شباب, this is the radius of the earth. Radius of the earth, it should be subscript يعني. RE, the radius of the earth, over 16, يعني the distance between the surface of the earth and the space shuttle, the space in the international space, equal the distance, the radius of the earth divided by 16. كويس. Just keep that in mind. As in the figure below, okay. What is the weight of what? Of 100 kilogram astronaut, this is the mass of the astronaut, inside the station. He's asking about the weight of a person here. The weight of a person in the, of course, we would expect that, as we discussed in the lecture itself, as you move away from the earth, the acceleration of gravity will reduce and the weight of the person also will reduce. يعني we expect that the weight of this person will be less than the weight of the same person on earth. يا ترى يبقى قد ايه؟ How to solve such a problem? W equal the mass times G. هنا يا شباب the mass is the same. The mass here is the mass there. He didn't say that the mass would be changed يعني. It shouldn't طبعا of course يعني. إنما sometimes هو بيفترض بيقول لك لو الماس اتغيرت، هي المفروض ما تتغيرش بس هي لو اتغيرت خلاص ماشي اوكي. But in this problem he said of course the mass is the same here and there. كتلة الشخص على سطح الأرض هي نفسها كتلته في محطة الفضاء دي. So W on Earth is m times g, where g is the acceleration of gravity here at the surface اللي هي 9.8. بس ده مش اللي احنا عايزينه، احنا عايزين W dash. W dash that's W dash. The weight of يا شباب مش السبيس شاتل، لا احنا عايزين ال weight of the person inside this one equal the mass that's it times g dash, where g dash is the acceleration of gravity at that height اللي المفروض تكون أقل من الجي. هنشوف. How to solve such problem? I would say look at that شباب g dash equal g. طب الأول خلينا نحسب الجي الأول يا شباب. g equal the acceleration of gravity here at the surface equal g capital the mass of the planet divided by the radius of this planet squared اللي هي RE. Just let us say it's R وخلاص مش لازم RE يعني. This is the acceleration at the surface. طيب يا ترى g dash بقى the acceleration يعني ده اللي احنا عايزينه. If we have g dash we will just multiply it by 100 we will get the weight at that height. g dash equal g m the same m. الام يا شباب اللي هنا دي هي كتلة البلانت مش هتتغير لو انت بعدت عنه. Okay. But it is divided by the radius square. هنا بقى مش radius شباب، هنا distance. هي الحقيقة دي مش radius الحقيقة يعني. This is not the radius. This is the distance between the point that you are measuring from and the center of the planet. هنا يا شباب this distance is exactly the radius، بتساوي radius فعلا لأنها على السيرفس. إنما لما أطلع فوق أكيد الديستنس دي اللي هي في المقام is not the same. It will be changed. It will be bigger. هتبقى قد إيه يا شباب؟ هتبقى r over 16 plus r the whole squared. ليه؟ من هنا لهنا يا شباب we have this distance which is r over 16 plus r. the whole will be squared. ناخد بالنا عشان ده معظم الخطأ بيجي من هنا. Okay? So it equals g m and r over 16 plus r the whole squared واحد المقامات يا شباب will be 16. So we have here 16 plus 1 16r يعني plus r over 16. This end up with g m. Let's just take this as common. مشترك الار مشترك ما بين يا شباب هيبقى جوه we have r then we have 17 over 16 اللي هي 16 plus 1. ناخد ده مشترك يا شباب بره يبقى 16 plus 1 17 over 16 the whole squared. يعني هتساوي g m the same. شباب ناخد بالنا ان m هنا هي كتلة البلانيت not the person. تحت هيبقى 17 على 16 الكل سكويرد مضروبة في r سكويرد. ربعت بس ده ف 17 على 16 سكويرد مضروبة في الار سكويرد. حلينا ده يا شباب هتساوي look at that 17 over 16 سكويرد تحت في المقام will be reverse it يعني المفروض تبقى 16 على 17 the whole squared مضروبة في الجي مضروبة في m divided by r squared. That's the acceleration of gravity at that height to the new height. It equals 16 over 17 squared g m capital divided by r squared. حلوة يا شباب. Look at that. What is the relation between g dash and g? Look at that. الجزء ده g. This is g, which means that g dash equal 16 over 17 squared multiplied by g. And we know that g is 9.8, so it should be in this case 16 over 17 squared times 9.8. How much is that? I think it should be something like 8.68 meter per second squared. As we expected, the acceleration of gravity at that height should be less than 9.8. It's 8.68 meter per second squared. The last step هو بيسأل على الويت of the person at that height. خلاص W dash equal the mass which is 100 times this new acceleration which is in this case 8.68. That should be something around 8.68, and this is of course in Newton. One more problem, and this problem is a little bit different than the previous two. It's related to a person inside an elevator standing on a scale. So we have a 100 kilogram man, this is the mass, in an elevator is accelerating upward of 1 meter per second squared. That should be the A, and upward means it's a plus. This is very important, شباب. When you say upward acceleration يبقى plus, downward acceleration يبقى negative. What is the force pushing upward on the man's feet? That's so easy. The force pushing upward on the man's feet would be Fn, the normal force, right? He is standing on the elevator now, or on the balance, Here we have the persons and the feet. He is pushing down, and we have the normal force. We have the that. We have explained that in more details in the class. Yeah. So we have the normal force here. So he's pushing down with a force equal Fn, or the floor of this elevator is pushing up by a force equal Fn. We have Fn equal W plus M times A, the famous equation that I've asked you to memorize it. W is the weight of the person. This is M times G plus M times the acceleration. Well, like acceleration here is plus, so it should be A in this case. Yeah, we have M G plus A will be 100 times 9.8 plus 1, and it will be 100 times 10.8. 10.8. Okay, شباب? And that should be something around 1080 Newton. Okay, شباب, I actually have been asked about this problem many times. So I thought I have to make a kind of videos trying to solve this problem for all the students. الحقيقة المسألة دي مش هقول صعبة, بس هي طويلة شوية, يعني محتاجة steps, more steps. So you have to move step by step. As you can see, شباب, we have a pulley, okay? We have a mass here, 25 kilogram, and on the other side we have a rope connecting the two, and we have a 35 kilogram there. طيب. The question is, what would be the magnitude of the acceleration of M1? This one. How much is the acceleration? هي بتتحرك acceleration? Of course يا شباب. Since we have different in the weight, that should be moving down, that should be moving up, and here we have difference in the forces. We have a net force and we have an acceleration. But don't be foolish, ما تتغشش يعني when we say the acceleration of the 25 kilogram. تقول لي لا, they are connected, they must be moving with the same acceleration as long as they are connected together. But the acceleration on the 25 kilogram is the same as the acceleration on the 35 kilogram, but with different signs. Actually with different signs. هقول ليش بقى. Look at that. The 35 لأنها أتقل شوية will be moving down. It will be much stronger than the 25, so it will be moving down like that. So the 35 will move in this direction, and the 25 will be moving in that direction. Remember شباب, we have to in this problem يعني normally we ignore the friction forces. كل الفريكشن forces, air and the friction with the body. Normally حتى لو ما قلتش في المسألة يبقى أنا في الغالب لازم اعتبر ان مفيش friction forces خالص. وبعدين to solve this problem شباب, we have to deal with the two blocks separately, of each one of them separately. يعني I would just look at each one of these blocks as a separate object. هشوف شباب, دي الطريقة بتاعتنا دايما. I would look at the object as a separate object, and then look at all the forces applied exerting on this object. شوف كل القوى المؤثرة عليه. So let us look at the 25 kilogram object, this one. How many forces acting on this object right now? 2. M1G, M1 اللي هي الكتلة بتاعت شوية. M1G الويت, force of gravity downward, and we have the tension force, قوة الشد, in this wire. This is upward. But we have two forces. Okay? Remember, this object is moving upward with an acceleration now هنسميها A. That should be plus. The other one, the 35 kilogram, is also affected by two forces. Its weight M2G, 35 times G, downward, and the tension force is upward. ما هو في قوة شد الحبل. طالما يا شباب normally in our problems يعني since the rope is so small يعني we can ignore the mass of the rope, we will assume that the two tension forces are the same. Otherwise we'll be having a problem. يبقى اعتمادنا هنا على ان two tension forces are the same. الاثنين بيشدوا بعض. قوة الشد هنا زي قوة الشد هنا. Remember, the 35 kilogram is accelerating downwards. A is negative. Then we will just deal with each one of them alone يا شباب. Look at that. I would say that I'm just treating this block first. This object احنا قلنا this object is affected by two forces. خلاص. Net force, let us say that F net equal this minus that. This is plus, this is minus. It should be T minus M1 times G. Remember, F net also equals M times A. The acceleration the object is moving with now. It's a plus. I'll just keep it plus. طيب بما ان ده بيساوي الاف نت وده بيساوي الاف نت يبقى الاثنين دول بيساوي بعض. So I can say that T minus M1G equal M times A. Then just put T as a, يعني as just in one side يعني. So T equal, that should go to the other side with this positive sign. هتبقى M1G plus M I'm sorry, that should be M1 of course, yeah. M1A. And just let this to be equation number 1. Then let us go to the second one, the second part. Here, the second object. The same. F net equal, F net in this case equal T minus M2. T minus M2G. ما تلخبطش بقى بين M1 and M2 يا شباب. Now we are dealing with M2. This is M1 and this is M2. ما تعوضش بأرقام دلوقتي. خليها زي ما هي، خليها رموز. Okay? Then afterwards إن شاء الله at the end we will just substitute the values. This one شباب. T minus mg. This is plus, then upward. This is minus because it's downward. And at the same time, F net, Newton's second law, equals the mass times the acceleration. The mass of this one, which is m2, times the acceleration. That should be in this case m2. Look at that شباب. Negative a. ليه? It's downwards. As we did here شباب, we will just equate these two equations. Let me بيساوي F net. So this equal that. T minus M2G equal minus M2A. This one. Just rearrange the equation. Just put T in one side. ده يروح هناك يبقى positive. يبقى M2G minus M2A. يعني أعتقد تتضح شوية. Okay. We have equation 1. We have equation 2. طيب. T equal يبقى this value equal that value. خلينا نعمل. يبقى M1G plus M1A equal M2G minus M2A. Remember, we would like to find the acceleration. A. احنا عايزين A. يبقى لازم نودي A في طرف لوحدها. يبقى هنعمل rearrangement of this equation بحيث نخلي كل ال A's في طرف وال G's في طرف تاني. طيب. So let us say for example that I will just get this value to this side. هي negative هنا تروح هناك تبقى positive. And that one will go there. هو positive هيبقى negative. Rearranging this equation, we will have the following. M1A, this one. Then I will just get that here. It will be positive M2A equal M2G, and that one will go there, will be with the negative sign, will be M1G. هنا يا شباب M1A M2A. خلينا ناخد ال A common. يبقى A M1 plus M2 equal G M2 minus M1. ما ننساش we are looking for A. A equal this divided by that. It will be M2 minus M1 divided by M1 plus M2. ما ننساش this is multiplied by G. لأن في G. Okay? This value divided by that value. خلاص, and we have all these values. M2 is the 35 minus 25 divided by 25 plus 35. The whole is times 9.8. That should end up with something like 1.65 meter per second square. We have another problem, شباب, related to the man inside the elevator, the apparent weight and the actual weight. And we have here a student stands on a bathroom scale in an elevator at rest on the 2nd floor. This is the beginning. Okay, the elevator was at rest of a 5-story building. Okay, 5 طابق يعني. The scales reads now while it is standing still. It reads 833. That should be the actual weight, W. As the elevator moves up, it's start to move now. The scale reading increases to 936. That should be in this case Fn. This is the apparent weight. What is the acceleration of the elevator? I would use the same equation, Fn equal W plus m times A. Then we have Fn, this is the apparent weight, this is the reading of the scale, which in this case would be 936. And the actual weight would be in this case 833 plus m times A. We can eat m times A. We can solve this problem in one case if we know how much is m. And of course m, we can get m easily because we know that W equal m times G. W is 833 equals m times 9.8. So m would be in this case equals to 833 divided by 9.8. So we have this value and we can easily find how much is the acceleration. Okay, شباب, so let us solve this problem as well. A falling skydiver, an object falling down of mass 100 kilogram, this is m, experiences 500 Newton air resistance, that should be F air. The acceleration of the skydiver is, should be, how much is the acceleration of the skydiver? How much is it? The acceleration of the skydiver. The problem is simply Newton's second law. Okay? We have to calculate all the forces, all the forces exerted on the object. This is the object. It is affected now by two forces, Fg, and it's also affected by F air, the air resistance upward, because it's moving downward with an acceleration. We need how much is the acceleration. It has a mass m. I would say using just Newton's second law, F net equal two things. F net equals m times A. This is Newton's second law, and also from the shape, from the sketch that we are drawing now, F net also equals F air minus Fg or W. You can say that Fg is the same as W. Okay, the weight here. So we can say that this equal that. Again, we can say that m times A equal F air minus Fg, and then we are asking about the acceleration. The acceleration would be in this case F air minus Fg divided by the mass. We have all of these values. We have F air, which is 500, and we have Fg, which is 100 times 9.8 divided by 100, and it looks like, of course, this value is bigger than this value, so the acceleration will be negative. It should be something around negative 4.8 meter per second square. Okay, شباب, we have this problem as well. This problem also is a kind of, an application of Newton's first and second law. But of course, we're gonna solve it using Newton's second law. A person inside a car, and the car will stop suddenly. Of course, according to the first law, the person will start to move, will continue moving because of the inertia. But he's not asking about the inertia now. He's asking about something else. How much is the force acting on the object? Let us read it. We have a 60 kilogram front seat passengers. This is the weight of this passenger. In a car moving, this is the mass, moving initially with a speed of 18 meters per second, that's the initial, is brought to rest, will stop by an airbag. والله بقى airbag, by the seat belt, the same, something that will stop it. حلو. يعني stop it شباب يعني we have the initial and the final will be zero. This is the main thing. When we brought it to rest means the final. I have to translate it like that. I have to interpret it like that. The final will be zero. In 0.4 seconds, this is the time. We have the initial, we have the final, we have the time, and what is the average force acting on the passenger in this process? He's asking about the force. I don't have any equation for the force except this one, F equal the mass times the acceleration, if I have the mass of the person and the acceleration the person would be moving with when it is brought to rest يعني, I will be easily find F. We have the mass but we don't have the acceleration. We don't have it directly, but we can easily guess it. How much is it? Because we know that the acceleration A equal V final minus V initial divided by the time. We have all of these. We have V final, which is 0. We have V initial, which in this case is 18. And we have the time 0.4. Okay, the 0.4. If we just calculate that, it will end up with negative 45 meters per second square. This is the acceleration that will the object this front seat passenger will be moving with when the car is brought to rest. هاخد الاكسلريشن دي خلاص. يبقى the force in this case, the force that would act on this object equals the mass times the acceleration. The mass is 60 kilogram times negative 4.5. That will end up with something around negative 2700 نيوتن. خلاص شباب، ناخد بالنا بقى شباب. لو انتوا خدتوا بالكم الريجوليشنز اللي اتبعتت لكم in the exam, talk about this midterm specifically يعني 202. مفيش اي نيجاتيف ساين، يعني حتى لو حليت مساله زي كده you might solve the problem and المسائل ممكن تكون فيها نيجاتيف، ما تتخضش مش مشكله، بس ما تحطش نيجاتيف ساين in the solution. يعني النمبرز اللي تحطه حطه من غير نيجاتيف ساين، احنا عايزين كده ما تحطش اي نيجاتيف ساين. حتى لو المساله بتاعتك خلصت على انها نيجاتيف ساين ما تحطش نيجاتيف ساين، just leave it as 2700 نيوتن just in this exam يعني. Okay شباب, we have another problem and this problem is related to the conservation of momentum. We have to expect one of these problems in the exam for sure. Yeah, we have to have one of the conservation of momentum problems in the exam. And the solution should be so easy if you understand the problem is in a good way. But we have an object that moves at a speed v. Okay, this is the first object moves with a speed v. It's unknown v. Collides, smash with an identical stationary object. Identical, and it has the same mass. So if the mass of the first is m, the mass of the second also will be m. And the second one is stationary, is not moving. The first is moving with v. Look at that, Shabab. I can draw it. If you draw the problem, if you sketch it, that makes things much easier. The first one that has a mass m is moving with velocity v. Will collide with an identical, يعني it has the same mass, but it is standing still, so the speed is 0. Okay? On a frictionless surface, كويس. Frictionless surface ما فيش أي فاقد فيها. Anyway, and the two sticks together, the two will stick together, يعني they will move together after the collisions. ما هو stick together يعني they will be having the same velocity after the collision. This is very important. What is their velocity after colliding? He's asking about the final velocity of both of them. ليه? Because they are moving with the same velocity afterwards. So the تاني the problem is simply this mass m is moving with the speed v, will collide with this one that is stand still. This is before. And after the collision, look at that, the two masses m and m will be moving with a speed, let us call it as, for example, x or so, anything here. We are asking about x. The conservation of momentum, شباب, the conservation of momentum states that the momentum of the first object, P1, plus the momentum of the second object, P2, before the collision, equal the momentum of the first plus the momentum of the second after the collision. Okay, let's just put these values before and after, substitute that. We know that P equal m times v, the mass times the velocity. Remember شباب, it's the velocity. طيب. So P1 is the mass, is the momentum of the first object, which should be in this case m times v. That's P1 plus 0. Why? Because P2 equals 0. Then the second object before was standstill, so it will be 0 in this case, equal P1 plus P2. So P1 has a mass m, and it will be moving with a velocity, let us call it as x, plus the momentum of the second, it's m as well, times also x. ليه يا شباب? Because we said that they are moving, they stick together, so they will be moving with the same speed. يعني mv equal to, I'm sorry, in this case, yes, I'm sorry, that will be 2m times x. Remember, we are looking for x. How much is x? But of course we can cancel out m now. M was m, and x will be equaling to 1 over 2 of v. That's it, or 0.5 v. يبقى the speed or the velocity after the collision of the two objects will be half the velocity of the first object before the collision. هنا مش محتاجين ارقام يا شباب، خلاص. هنا المسألة دي مش محتاجين ارقام، يعني how much is it relative، يعني how much is the final velocity relative to the initial velocity of, or the velocity of the first object before the collision. So x is 0.5 of v. So let us look at this problem as well, شباب. It looks easy actually, while I have many mistakes of many of the students about understanding this problem. Okay, شباب? The problem again is, do we really understand Newton's second law, that F net equal the mass time the acceleration? And what does it mean the acceleration equals 0? شباب خلاص خلينا نحل بس. A worker is trying to slide a wooden box as in the figure below. He's try to push it here. He pushes the box by a force of 100 Newton. Okay, that is 100 Newton. Due east. Okay, positive. But the box doesn't slide. It's not moving. He is pushing, but the object is not moving. Static pressure, static friction. There is a friction between the box and the floor, of course, that prevent the box to move. It's the friction force. What is the magnitude of the force of friction? طبعا of course this question شباب was having some many choices يعني. From these choices, FB equal 100, F friction equal 100, more than 100, and less than 100. Many students said that F, as long as the object is not moving, this box is moving, معناها ان ال F friction is bigger than FB. This is totally wrong شباب. ليه؟ If this force is bigger than this one, يبقى net force تاني, net force on this object will not be zero. هيبقى في value. And if we have a net force, ماليش علاقة بقى يا positive ولا negative. طالما في net force يبقى we have an acceleration. وطالما في acceleration يبقى the object must be moving. طيب the question, is it moving؟ لا, ده انا بقول لك ان stand still, يبقى اكيد ده غلط. The object is not moving معناه ان acceleration is zero. Acceleration is zero يا شباب. Remember the statement that I'd asked you to memorize. Acceleration equals zero. The net force equals zero. They live together and they die together. An object is stand still, يبقى ما فيش أي solution تاني عشان غير إن ال acceleration equals zero. A equals zero means F net equals zero. And we will start from that. طيب يا ترى ال F net هنا from this sketch بتساوي كام؟ F net, we have two forces. It equals this one minus that one. This is plus, this is minus. It should be FB minus FF. And it equals to zero. لأنها بتساوي zero. يبقى FB equal F friction equal 100 Newton. Okay, one more problem. So we have a lamp. We have a lamp hangs vertically from a cord in an elevator which is descending, going down, with a downward acceleration. Should be negative in this case. Downward acceleration, and the acceleration should be in this case negative. The tension in the cord is 10 Newton. What is the mass of the lamp? Here we have the elevator. We have a lamp, and this lamp is suspended by a wire, by a thread. We should have a tension force here. The tension force is 10 Newton, and it's a plus because it's upward. And this lamp, of course, has a mass, so it has a weight. The weight is mg. The question is, how much is this mass? Remember, the elevator and the lamp is descending. They are moving down with an acceleration equal negative 2 meter per second. مش هيقول لي هو نيجاتيف، بس هو قال لي ان هي downward acceleration، يبقى should be negative in this case. هجيب الماس ازاي؟ so simple شباب. هقول ان F net equal the mass time the acceleration, right? This is Newton's second law. It should be in this case mass time negative 2. This is the first part. خلاص خلصنا. Let's go to the second part. F net also equal the total force. The total force from this sketch is we have two forces, T upward plus and Fg downward. So it should be T minus mg. And this should equal that. F net يعني T minus mg equal m times a. T equal mg. I will just put that in the other side with a positive sign, plus ma. So it equals m as a common, وعندنا g plus a. وبعدين نحط الفاليوز أو نحط ال a. Oh, I'm sorry, الm يعني. m equals t over g plus a. تساوي t is 10 Newton, g is 9.8, and a is negative 2. So it's 10 divided by 9.8 minus 2 زي ما تكون ماشي. I think it should be something like 1.3 kilogram. So in such a problem, شباب, as you can see, we have two blocks, the 1 kilogram and the 3 kilogram, and they are exerted by two different forces from two different sides, 5 Newton to the right, 3 Newton to the left. And the question is, what is the acceleration of the 1 kilogram? He's asking about the acceleration of this one. Don't be fooled by such a question. Don't think that the 1 kilogram will be having a different acceleration than the 3 kilogram. يا شباب, they will be moving smoothly with each other, which means they will be having the same acceleration. The 1 kilogram and the 3 kilogram will be having the same acceleration. How to get this acceleration? Using Newton's second law. F net equal the mass times the acceleration, and the acceleration equal F net divided by the mass. Okay? The net force would be this one minus that one. This is plus, this is minus. So should be in this case 5 minus 3. And the mass. What mass we have to put here, Shabab? The mass of the whole system, because they are moving as one object. So the mass would be 4. So we will end up with 2 over 4, or we have 0.5 meter per second square.